to find the number of k permutations of n elements. First, select which k elements will be in the permutation, then count how many ways there are to arrange them. Once you have selected the k objects, we know there are k factorial ways to arrange or permute them. But how do you select k objects from the n? Well, you have n objects, and you need to choose k of them. You can do that in n choose k ways. Then for each choice of those k elements, we can permute them in k factorial ways. Using the multiplicative principle, we get another formula. Let's take a look at this. This means that P n k equals n choose k times k factorial. Now, since we have a closed formula for P n k already, we can substitute that in. So that means that n factorial divided by n minus k factorial equals n choose k times k factorial. Now, if we divide both sides by k factorial, we actually get a closed formula for n choose k. We can solve for n choose k, and we get this formula. N choose k equals n factorial divided by n minus k factorial times k factorial. So we say Pnk counts permutations, and n choose k counts combinations. The formulas for each are very similar. There is just an extra k factorial in the denominator of n choose k. That extra k factorial accounts for the fact that n choose k does not distinguish between the different orders that the k objects can appear in. We're just selecting or choosing the k objects, not arranging them. Perhaps combination is a misleading label. We don't mean it like a combination lock, where the order would definitely matter. Perhaps a better metaphor is a combination of flavors. You just need to decide which flavors to combine, not which order you combine the flavors. Anyways, thanks everyone, and I'll see you in the next video.